Hi, everybody, and welcome back. This is part 2 of our AI Pyramid series. And tonight we're doing this masterclass called AI Hardware. And these are the silicone toll booths powering the AI gold rush. And today we're going to go over the 5 companies sitting in the middle of this AI stampede. I'm Joe Markman, and this is Markman Capital Insight. And our mission is simple: help self-reliant investors ride the great digital transformation of our lifetimes early and often, without getting wrecked by hype and political cycles. You know how easy it is to get caught up in hype and political cycles. Don't do that. All right, let's dive in. All right, so everyone knows Nvidia won the first inning of AI. What almost nobody's mapping yet is this. Over the next decade, the real money won't just come from guessing the right apps or the right chatbots. It's going to accrue in the toll booths that every single AI winner has to pay over and over again. And tonight, we're going to move up one layer in our AI pyramid, and I'm going to do 3 things for you. First, I'm going to give you a simple investor-grade map of the entire hardware stack in plain English. Second, I'm going to walk you through 3 core positions I think every serious AI portfolio needs to at least understand, and those are Nvidia, ARM, and Broadcom. Then I'm going to introduce two smaller plumbing plays. And one of them is including a company that is quietly dominating the active cables that link AI clusters together. And by the end of this, you'll see exactly where the hardware tolls get collected and which tickers sit right in the middle of that cash flow. So let's zoom out for a second. Some of you might be thinking, what is this AI pyramid? Well, it's how our company, and actually recently how Jensen Huang identifies the AI tech stack. Let's go over it. So AI is not just an app. It's an industrial stack that has 5 layers. Starting at the bottom is power and infrastructure at the base. Now that was the part 1 of our AI pyramid series. We covered all of those people. Step 2 is the chips and the hardware, otherwise known as the silicon engines. The third layer is the data infrastructure. Fourth is what's referred to as the models and enterprise AI platforms. And the fifth, those are the apps on top. Those are the stuff that shows up in the headlines. That's Tesla FSD. That's OpenAI. All right. So last time we talked, we lived exclusively at the bottom. That's power. That's the electrons. And if you haven't watched my AI X Power Masterclass, please do that after this. This will all make a lot more sense. It'll make everything we covered tonight click exactly into the right place that it's supposed to be in. And especially the energy side, because you really need to understand where this all starts. All right, so tonight we're climbing up one layer and we're talking about chips and hardware. The chips, the memory, and the little bits of plumbing that turn cheap electricity into intelligence. If power is the oil field, this layer is the refinery and the pipes. It's where raw input gets turned into something the rest of the pyramid can actually use. And just like in the early days of the oil industry, only a handful of companies end up owning all the refineries, the pipes, and the valves. And that's where we want to spend our time as investors, in those places. All right, so let's connect it back to layer 1. This is the idea from our first masterclass. AI at its most basic level is just this. It's electricity that's turned into floating point numbers, which are then turned into in intelligence. It's really that simple. But I mean, it's a complex process, but it's that simple. We take electricity flowing into a data center, chips chew up the electricity and turn that into math. And out the other side, you get predictions, images, codes, drugs, robots, all of it. It takes electrons, recognizes patterns of those electrons, and then we ask it to do things. And those patterns reassemble into those things that we ask it to do. And tonight is all about the layer where that conversion happens. We're not buying vibes. We're buying the factories that turn power into compute and compute into cash flows. This is important. And we have to remember, our jobs as investors is simple. Own the companies that monetize conversion every time it happens. No matter which app is hot this quarter, these companies are the ones that are monetizing that conversion. All right, so let's get into the stack. The hardware world can get very technical very fast. And that's how people get intimidated and sit out the opportunity. So let's keep this investor grid. We're going to break the hardware layer into 4 buckets. First, we're going to talk about compute. That's the CPUs, the GPUs, the ASICs, the FPGAs. These are the brains of the operation. Next, it's the memory. Especially today, we're going to talk about high bandwidth memory, or HBM. This is the food for the entire system. Interconnects, the links between chips and racks. This is how we talk to each other. This is the nerves and arteries. Next, we have edge and inference. That's the 4th bucket. This is running AI on phones, cars, and small devices where power is scarce. Everything you've heard about AI hardware lives in one of these 4 buckets. So our focus tonight, where are the natural toll booths for each of these buckets? Who's getting paid on a pay-per-play basis? Let's find out. First, let's dive into compute. There are really 2 economic games here. First is training. This is where you build the model. Huge batches of math, massive amounts of data. It's like teaching a pilot to fly in a simulator. You care about raw horsepower. That's where GPUs and chips like Google's TPUs shine. Then there's inference. This is where you use the model. Billions of small requests. Answer this prompt, steer this car, flag this transaction, create this image, model some portfolios. You get the gist. And what's important about inference here is you care about low latency and power efficiency. So that's speed and how much power you're drawing, or your bill. So speed and bill. So why does this matter? Well, because different companies dominate different parts of that split. Nvidia still is the king of training. But inference is more fragmented, and that's where efficient architectures like ARM's specialized ASICs eat away at old CPU models. So when you see the headlines, always translate them into this. Is this training CapEx or inference CapEx? Is it training or inference? And who is the toll collector? Who's the toll collector? That's important. All right, now here's a dirty little secret. The chip is only as valuable as the data it can swallow per second. Most AI systems are not limited by how fast the math unit can crunch numbers. They're limited by how fast you can feed it data. That's the memory bandwidth bottleneck. High bandwidth memory, or HBMs, is basically a very wide, very short highway leading right into that chip. Picture a multi-lane ramp on a freeway feeding a racetrack at full speed. It's basically Los Angeles. You got 8 lanes on both sides, massive on-ramps. That's what we're looking for in high bandwidth memory. Without it, your fancy GPU just sits there waiting around like a race car idling in the pits with no fuel. You really need high input. This is very important here. And as investors, this matters because high bandwidth memory and memory bandwidth directly cap how much revenue you can squeeze out of a rack of hardware. That's why you see these insane order books for high bandwidth memory suppliers. It's glued to AI build out. The more memory you can jam through a chip, the more you can output and the more you can charge. So these are really the cap on revenue. And that's why it's so important. So the 3rd bucket, interconnects. So one GPU is very impressive. I mean, they're 70 pounds each. They are basically an entire server in one chip or in one chip. They're magnificent beasts. But when you string a few thousand of them, you can actually get them acting like one. And that's where the real magic is and the real costs live. Those GPUs need to talk to each other quickly, reliably, and over distance. I mean, these aren't small spaces. Without the signal turning into mush or the power draw going off a cliff. On the proprietary side of these interconnects, you have Nvidia's NVLink and InfiniBand. That's their private toll road. And those are 2 incredible beasts. The NVLink can move more data through its spine in one day than the entire internet can generate in terms of data traffic. They're beasts. On the more open side, you've got things like UA-Link and Ultra Ethernet, where companies like Broadcom lean in and dominate. This is also where our 2 smaller names, so 2 names we'll be discussing more later, live. This is Astera Labs and Credo. They both live in this side of the interconnects buckets. They don't make big flashy chips. They make the plumbing and let those chips scale. They let the plumbing that allows those chips to scale. The last piece of hardware on this map is the edge, the inference. This is AI running on your phone, in your car, in a robot, in a sensor, or on a factory floor. You can't strap a full data center to the back of a Tesla or an iPhone. You need small, efficient, specialized silicon devices to do all that. And that's where architectures like ARM shine. They are on a performance per watt. And it's where companies like Qualcomm, Apple, and Tesla's in-house chips all build on that foundation. So they're all building on ARM's IP foundation. This is very important. The big idea here is simple. As AI spreads from the cloud into every device, the number of chips explodes. And the companies that license the blueprints and own the low power design get paid every time. So that's very important. All these other companies that are building chips that are outside of Nvidia, they're all building it on ARM IP. So we must pay attention to that. Okay, so that's the map. Those are the four buckets. Now let's dive into specific toll booths. So with that map in your head, we're going to zoom into 3 hardware positions. These aren't the only opportunities in the space, but they're the ones that I view as structural toll collectors in the AI build-out. There's always going to be smaller companies, but it's important to note that we are in an investing phase in the market. This is more of a macroeconomic thing, where the main companies are the ones that are driving revenue share. So they're the ones driving actual profits, cash flows, and the market higher. So you do need these companies in your portfolio to participate in the gains being from hardware. There's always going to be someone else or some other small company doing some small thing. And if they ever become important, these big guys are likely to buy them. So it's not something to glance over, and you do need to understand these 3 big guys. They're big for a reason. So we have in Nvidia, this is the AI training tax. We have ARM. This is the efficiency landlord for CPUs and NPUs. And then we have Broadcom. These guys create the custom silicon and Ethernet backbones for all the above. So think of these as the anchors. And then we'll layer on 2 more specialized plumbing plays for those more smaller companies that, people tend to want to have in their portfolios as well. All right, so let's start with the obvious one, NVIDIA. Right now, NVIDIA controls the vast majority of the data center GPU market for AI training. Their H100s and their new Blackwell chips, they've become the performance benchmark, hands down. If you're a hyperscaler or a lab and you want to train a state-of-the-art model, most of the time, you're going to end up cutting a check to NVIDIA. And most of the time, every time when you can. But the real story isn't the chip, it's the system around it. And that's what turns NVIDIA from a hot stock into a structural toll booth. NVIDIA has an incredibly large moat. NVIDIA's biggest asset is a piece of software most people never see and laymen have never heard of. It's called CUDA. CUDA is a programming framework that AI developers have been building on for more than a decade. It's the toolkit. It's the library. It's the whole ecosystem. It's literally a plug-and-play toolkit for the most specialized things. You could be doing machine learning. You could do AI vision. You could be doing hyper-advanced math. You could be doing something super small and lame. And CUDA has already built a library with pre-programmed language that you can just put into your application to use. It's incredible. And they started building it before anyone even knew it was a thing. It's incredible. If you're a developer, you've invested years in the CUDA skills and CUDA code. In fact, universities even teach CUDA in their classes. It's that important. Switching away from that to a completely different stack is slow, painful, and expensive, and it will require years potentially of research to recreate the stuff that NVIDIA has already done for you. On top of that, NVIDIA owns the entire vertical. They own the GPU, the NVLink, which is the thing that connects GPUs together, and then through something called Mellanox and InfiniBand, the network that ties the whole clusters together. So NVIDIA owns the entire software library and hardware stack. So software library and hardware stack that enables all of this. And it works fantastically. So when you hear NVIDIA is expensive, remember, you're not just buying a chip company. You're buying the operating system of AI training. Plus, these are the toll roads that everyone must pay to play on. Back to our pyramid for a second. Nvidia lives smack dab in the middle of layer 2. And as the king of training compute, it reaches into the interconnect space with InfiniLink and InfiniBand. Risks, I feel like I have to say sure, but not. I mean, Nvidia is AI at this point. They own 96% of the market. AI capex can be lumpy. So in terms of investor risk, yes, there will be volatility within the market. And competitors like AMD get a lot more credit than they deserve, which does hurt the stock price sometimes. And also, regulators don't love extreme dominance, but the current administration is playing very well with Jensen Huang, so we don't see that as an immediate risk. But if you want to zoom out, if you believe AI is the next internet level transformation, then every major model training cycle asks the same question. How many of those dollars avoid NVIDIA? Historically, the answer has been not many. In fact, Jensen had a quote saying that even when other companies try to give away their chips, it's not cheap enough because the amount of support and software around the chip is so incredible that NVIDIA allows you to use that free isn't cheap enough. Let that sink in. All right, let's switch it up. This is name a little bit more behind the scenes. It's ARM. We believe this is one of the companies down. ARM doesn't run giant fabs. It doesn't ship finished chips. ARM licenses blueprints to others to build and create. Their designs sit underneath almost every low-power processor you touch. That's phones, tablets, embedded devices, and now increasingly data center CPUs and NPUs. Cloud giants like Amazon with Graviton and Google with Axiom and Microsoft with Cobalt, all of these are ARM-based. Now, I know I'm throwing a lot of terms out there. You really don't need to know any of them. Essentially, each company has their own version of chip that they can use for this, and they're all building it on top of ARM's specialized specialized IP. So ARM's business is to be an efficiency landlord. They create the architecture, and everyone else pays rent to them in royalties. It's crazy. ARM really is an actual tollbooth operator. So how does this all tie into AI? So remember the split between training and inference we talked about in the beginning of this talk? Well, training tends to live on the monster GPU clusters. Inference, actually running the model a billion times a day, increasingly lives on efficient CPUs and NPUs, especially at the edge. ARM's low power designs make it possible to cram AI capabilities into phones, cars, routers, tiny devices, and even custom cloud CPUs that sip power instead of chugging it. Every time a chip designer chooses ARM's architecture for an AI-capable device, ARM doesn't care whose logo is on the box. Not at all. They just collect the royalty stream. Anyone can build on top of ARM. In fact, everyone should. So as AI spreads into everything, ARM gets a quiet, leveraged play on that proliferation. They ride everyone else's success because everyone is building on them. On our pyramid, ARM sits inside layer 2 as the foundation for a huge share of inference and edge computing. It's not as flashy as NVIDIA, and the revenue doesn't spike the same way around each training cycle. But structurally, if we move toward a world where AI is just a feature of every device, ARM's blueprints are like owning the street grid of that world. They are the toll booth operators of this world. All right, so the third core name is Broadcom. Broadcom does two things extremely well in this context. They build custom ASICs for the biggest players on earth. Think of chips built specifically for Google and Meta, other similar hyperscalers. They dominate network switch silicon. That's the brains inside fast Ethernet switches. They move data around a data center. So when a hyperscaler says, we want our own AI chip tuned exactly for our workloads with our secret sauce, Broadcom is often the trusted design and manufacturing partner for this process. And when the same hyperscaler builds out rows and rows of AI racks, the switches that connect all that hardware are often powered by Broadcom silicon. It's pretty incredible. Broadcom is also a big player in the push towards open alternatives to NVIDIA's closed system. They're central in things like the Ultra Ethernet Consortium and UA Link, which is an industry coalition's trying to make high performance AI networking run on more open Ethernet based standards instead of purely proprietary fabrics. This is a direct reference to NVLink at Nvidia. So why does that matter? Because if hyperscalers can get 90 to 95% of Nvidia's performance, but on a more open, cheaper multi-vendor stack, that's attractive. And Broadcom sits right in the middle of that hardware. So you've got this interesting barbell here. On one side, you have NVIDIA with the closed high-performance private toll road, even though with NVLink, you can use other chips to connect with it. So they're kind of trying to control the open source too. But on the other side of the barbell, you have Broadcom and friends building the open, but still very public highway. Either way, data has to move, and Broadcom gets a piece of that. All right. So on the pyramid, Broadcom lives in layer 2 as both a custom compute partner for hyperscalers and a networking backbone provider for AI data centers. If you drew a simple money flow diagram, every $1 spent on AI data center hardware, some fraction flows into custom chips and switches. Broadcom's job is to capture as much of that as possible across multiple customers, not just one. All right, so let's get into the plumbing pure plays. All right, so that was the big three, but now let's zoom in on two more focus names that live down in the plumbing, where most investors never look. These are not everyone's got to own names. These are for people comfortable with a bit more volatility in exchange for more direct leverage to the AI build out. We'll start with Astera Labs. Then we'll finish with the one I'm most excited about, which is Credo. To be fair, I'm excited about both, but Credo is a cool company. Remember the memory bottleneck we talked about that high bandwidth memory solves? Well, even with high bandwidth memory glued into a GPU, you still run into situations where you want your accelerators to see larger pooled memory. Think sharing huge amounts of data across a cluster instead of being limited to what fits right next to each other or right into the next chip. Astera Lab focuses on connectivity using standards like CLX, which is basically a smart, high-speed bridge between compute and shared memory resources. Their hardware lets data centers create giant, flexible memory pools that GPUs and CPUs can tap into. That helps break the so-called memory wall without having to reinvent the whole system. So in our hardware stack, Astera sits between the compute, which is your GPUs and CPUs and accelerators, and the expanded memory pools they want to talk to. As models get larger and more memory hungry, the pressure on that layer increases. If you can ease that pressure, you provide a lot of value. Again, this is not a mass market name, but if you want a more targeted exposure to AI connectivity and memory pooling, Astera is one of the cleanest pure plays there. Now, let's talk about Credo. Before we get into what they do, I want you to picture something. You've just spent hundreds of millions of dollars on GPUs, CPUs, racks, and powers. I know, completely relatable, right? I'm sure everyone out there is spending hundreds of millions of dollars on cutting edge tech. All that hardware is only as valuable if it can talk to itself reliably at insane speeds over and over again for years. And if that signal degrades, if the power draw is too high, if the links between the racks fail, it's like building a world-class highway system, then using dirt roads between the on-ramps. That's the world Credo operates in. Credo focuses on high-speed connectivity inside data centers. That's active electrical cables. These are not your basic copper cords. Oh no. They have electrons inside to clean up and boost the signal over distances. So it's not just a signal through a medium, it's a signal through a medium also boosted by other purposely placed signal enhancers, basically electrons helping other electrons go fast. They have retimers and size. These are chips that sit in the path of the signal to maintain integrity at very high speeds. This is like 800 gigabytes and above, which is insane. I'm sure none of us have ever touched speeds like that. That's like the web page loading before you even click send. Their edge is pretty simple to explain. They're very good at building low power, high performance electrical connections that are cheaper than going to full optics everywhere. but still deliver the speeds that AI clusters need. So they fit this happy medium. In other words, they help you string GPUs and switches together efficiently at scale without wasting energy or losing any of that valuable signal. In the emerging AI center buildout, Credo has become a dominant supplier in these active cables. It's a tiny line item on a hyperscaler's budget, but it's non-optional if you want the system to work. So why am I so excited about Credo? Why am I excited about Credo as a high upside idea? Well, it's because their economics are leveraged to AI capex growth, but without having to win the GPU war. Every time a hyperscaler builds a new AI rack, they buy the GPUs, the switches, the memory, and the cabling and retimers that tie it all together. Credo lives in that category. You don't get paid for the headlines. You get paid for the fact that nobody wants to rip out thousands of active cables and redesign their network every year. Once you're qualified and designed in, inertia is your friend. Of course, this comes with risk. There's customer concentration. There are a few big buyers out there. I mean, the Mag 7. I mean, there's going to be more with Oracle, developing their own sovereign AI and bringing hyperscale sized data centers to the masses. But for now, there's only a few customers. There's competition. Others do want that slot. So there are a few other competitors, but nothing to the scale or the technical prowess of Credo. And there are cycles in AI and cloud capex or in cloud capital expenditure. So there are cycles to this thing. So positioning size matters. But as a way to own a slice of the plumbing inside the AI build-out, I really like this profile. It's a good one. On our pyramid, Credo is deep inside layer 2. It is the interconnect sublayer. If Nvidia is the big flashy engine, Credo is the wiring harness and the nerves making sure the engine actually talks to the rest of the car. No one goes to the World's Fair to look at wiring diagrams, but without them, the lights just don't turn on. If you go back in history, a lot of fortunes and new technologies weren't made in the obvious places. They were made in the connectors, the rails, the pipes, and the genes that everybody else took for granted. Credo has a shot at being one of those in this AI story. All right, let's zoom all the way back out. Here's how I think about these 5 names in the hardware layer. Nvidia, that's the default tax on training, that's the default tax on training and the biggest models and the best hardware. ARM, they're the efficiency landlord for inference and edge. Broadcom, that's the custom silicon and Ethernet backbone in all AI data centers. Astera Labs, that's a targeted play on memory pooling and CXL connectivity. Then Credo, a targeted play on high-speed electrical links and active cables inside the AI clusters. And together, all of this, they give you a nice cross-section of the silicon tollbooths powering this AI gold rush. Now, so great, you have all this information in these 5 companies, but how do I actually use this in my portfolio? Well, I'd separate them into 2 different categories. One is the anchors. That's Nvidia, ARM, and Broadcom. These are the core structural positions tied to the long-term AI hardware build-out. These we would consider core holdings. Buy when the markets are in a little bit of a dive, when trade talks are in the air or something's in the air and the market's a little uneasy. These are your core holdings you buy in those dips and don't sell. High upside plumbing, this is the next category. So high upside plumbing. This is Astera and Credo. These are smaller allocations, a little more volatile, but with very clean leverage to specific bottlenecks. We would size them according to risk and rebalance into weakness where it makes sense. And most importantly, we stay invested through the cycles because we only really believe in bigger secular cycles or secular trends. And all of this is within the secular trend of the great digital transformation. And within that sub-trend, we have the AI phase of the great digital transformation. And that's also a secular trend. Secular is defined as 5 to 10 year cycles. It's 5 to 10 plus year cycles. AI hardware is going to be cyclical. There will be overordering, digestion phases, scary headlines. But it's the same story we saw in all waves. That's PCs, smartphones, clouds, all of it. But missing the secular transformation is far more damaging to long-term wealth than riding through a couple 20% drawdowns with sizing positions you can emotionally tolerate. This is very important. A lot of people ask, what's the appropriate size for your portfolio? We have recommendations and sizes, but if those sizes are too big, that if it drops down 20% and you can't sleep at night, then that size is too big for you. Investing is for wealth, but it also needs to be for health. And if you're staying up at night, you're doing something outside of your comfort zone, and that's not all right. And so you should tailor your investing experience to match that. All right, so let's wrap this up. In part one, we tackled the power layer. That's electrons. Tonight, we mapped the hardware layer. That's the silicon and the plumbing. And next up, we're going to climb up the ladder, or the pyramid, to layer 3, which is data infrastructure. This is the software and systems that turn raw floating point numbers into usable intelligence. And if you found this useful, go back and watch the first one on power. It's the base of the pyramid, and it is very important to understanding the entire stack. And if you want ongoing updates on this, as this AI hardware story involves, that's new winners, new research, the changing risk, or better entry points, which we do provide, make sure you're on the newsletter and in our research. The same principle. Well, it's kind of an aside, but this is the same principle. I did a 260-mile canoe race in 2025, and I learned one thing from that race was just don't stop. Whatever you're doing, just don't stop. There's always going to be distractions, reasons to stop, reasons to take a break. But the important thing is just stay on the water and paddle and just don't stop. And I feel like trading in the stock market is very, very similar. Pick your trends, pick your rivers, pick your secular trend, which is your river. Find the positions that are smart within that section. Stay invested, position smartly, and ride that wave, baby. And above all else, thank you for watching. My name is Joe Markman, and here we defend returns and we ride the digital transformation, and we just don't stop. If you like this or anything else, subscribe to our free newsletter. It's called the 3% letter. It comes out every Friday, and there